I'm in the beautiful campus of IIT Kanpur, and I'm just outside a center called Pioneer Batch 1965 Continuing Education Center. Just outside the center, I get interested in these tiles, and I'm attracted to analyze the symmetry of this tiling. Here Here is my stationery to do the analysis, and here is the tiling. So first, let me mark the lattice points of the tiling. I have used 4 champa flowers to mark the 4 lattice points defining a primitive square unit cell. The lattice parameters are equal on the two sides A and B, and the angle between them is 90 degrees. But is it really a square pattern? Because squareness depends not only on the relationship between the sides, that is the dimensions of the unit cell, but actually the symmetry. So let's look at the symmetry of the pattern. If we look carefully at the lattice points, there are no fourfold symmetry characteristic of a square lattice. In fact, there are only vertical mirror planes, which I will now mark with my mirror line markers, which are these sticks. So I place the stick there to define a mirror line, another stick there to define another mirror line, and of course, if the mirror lines are passing through the lattice point, they will also pass through the center between them at half the separation. Thus, apart from the translational symmetry, the only symmetries are these vertical mirror planes. One set of mirror planes defines a rectangular lattice and not a square lattice. So, this pattern turns out to be a rectangular lattice with accidental equality of A and B. Despite A and B equal, we will call rectangular lattice, and the symmetry turns out to be PM.